All right, welcome. Today we're going to pull back the curtain on some simple but super powerful physics that's hiding, well, pretty much everywhere, in the most common tools you use every single day.
So, to get our brains warmed up, how about a quick little puzzle? Let's just see if we can spot the secret connection between a few objects that seem totally random. Okay, so take a look at these three. On the surface, they've got nothing in common, right? A seesaw is for the playground, a wheelbarrow is for yard work, a fishing rod is for, well, fishing. But believe it or not, they all share the exact same fundamental design principle. Any guesses?
And that's right, they are all levers. Every single one of them. Perfect examples of one of the most basic, simple machines out there. The real magic, though, is how each one uses that same core idea in a slightly different way to get the job done.
Okay, so let's get into that blueprint. To really get how these tools work, we've got to break the lever down into its most basic parts. And it all comes down to just three essential components. First up, we have the fulcrum. You can just think of this as the pivot point. It's the one part of the whole system that stays put while everything else moves around it. You know, like the very center of a seesaw? That's your classic fulcrum. Next, you've got the load. This one's pretty simple. It's just the object or the weight you're actually trying to move. It's the resistance you're working against, whether that's a giant rock or, just a stubborn cap on a bottle. And finally, there's the effort. This is the force you bring to the table. It's your push or your pull that you apply to make the whole thing work. So here's the key takeaway, right? Every single lever, no matter how simple or complex it looks, is just a combination of these three things. A pivot point, something you want to move, and the force you use to move it. Fulcrum, load, and effort. That's it. Okay, but here's where it gets really cool. How do we get from that one simple blueprint to all these different tools? Well, it's all about the arrangement. Just the order of the fulcrum, load, and effort creates three totally distinct classes of levers. All right, let's kick things off with the one you probably think of first, the first class lever. I like to call this one the balancer. So in this setup, the fulcrum is sitting right in the middle, sandwiched between your effort and the load. You push down on one end, the other end goes up. Simple as that. The big advantage here is that it can either multiply your force, making you stronger, or it can completely change the direction of that force. A seesaw is obviously the perfect example, but you see this everywhere. Think about a pair of scissors. The little screw in the middle is the fulcrum right between your fingers and the blades cutting the paper. It's the same idea with pliers or when you use a crowbar to pry something open. Next up, let's talk about the second class. This one is an absolute powerhouse. It's what I call the force multiplier. Here, the arrangement gets a little shuffle. Now, the load is in the middle, between the fulcrum and where you apply the effort. And this design gives you this amazing thing called mechanical advantage. Basically, it means you get way more force out than you put in. A little bit of effort can move a really, really heavy load. And this is exactly why a wheelbarrow is so genius. The wheel's axle is the fulcrum. The heavy stuff, the load, sits in the middle. And you apply your effort way at the end when you lift the handles. A nutcracker? Same thing. A bottle opener? Yep, that's a second-class lever too. And that brings us to our final type, the third-class lever. This one is completely different. It actually trades all that raw power we just saw for something else entirely, speed and a wide range of motion. It's the speedster. So in this class, the effort gets applied between the fulcrum and the load. Now, here's the interesting part, the trade-off. You actually have to apply more force than the load itself. I know, it sounds inefficient, right? But what you get in return is that the end of the lever moves much further and way faster. You're trading brute force for speed and precision. A fishing rod is the perfect example here. Your wrist, holding the bottom, is the fulcrum. You apply the effort with your other hand somewhere in the middle, and the load, well, that's the fish at the very end of the line. A tiny flick of your hand sends the tip of that rod flying a huge distance. Same principle for a pair of tweezers or even sweeping with a broom. So let's just pull this all together for a second. It's pretty amazing, right? Just by changing the position of one of those three parts, the fulcrum, the load, or the effort, you create a completely different kind of tool. You can get a balancer, a force multiplier, or a speedster. It's just an incredibly elegant and simple system when you think about it. All right, now for the final and maybe the most surprising connection of all. We've been talking about tools you find in the garage or in the kitchen,
But what about the tools you carry around with you literally everywhere you go?
Believe it or not, our own bodies are just packed with these simple machines. Our bones act as the levers, our joints are the fulcrums, and our muscles, they provide the effort to move all kinds of loads. Just think about your arm when you lift something. Your elbow joint, that's the fulcrum. Your bicep muscle, which attaches to your forearm just past the elbow, that's where you apply the effort. And the load is whatever you're holding in your hand. It's a perfect third-class lever, designed not for power, but for speed and a huge range of motion.
So I'm going to leave you with this final thought. Once you see this simple pattern, fulcrum, load, and effort, you really can't unsee it. You'll start noticing it absolutely everywhere, from opening a door to digging with a shovel. This simple machine isn't just in your toolbox. It's all around you, and it's even part of you. So the question is, what levers will you find today?